Welcome to online lecture series in organic chemistry, and we are discussing the organometallic compounds, reactions of organometallic compounds. Next reaction is redistribution reaction of organometallic compounds. When two derivatives of the same element, for example mercury, zinc, gallium, boron, germanium, tin, etc., interact, then there is an exchange of groups between the same element. Such a reaction, it is called as redistribution reaction. We'll take example. Suppose dialkyl mercury is mixed with dihalogen mercury or dihalide mercury. These are the two derivatives of same element, that is mercury. Then there is an exchange of alkyl group and halogen atom in the same element, that is mercury, and we get new organometallic compound, that is halogen alkyl mercury. So this is redistribution reaction. Another example is when dialkyl zinc is mixed with dihalide zinc, then there is a redistribution of halogen and an alkyl group between two zinc atoms, and we get new organometallic compound. Now here zinc is attached to one alkyl group and one halogen atom. This is new organometallic compound. Actually this R is any alkyl or aryl group, X is halogen atom. It may be chlorine, bromine or iodine. Similarly, when trialkyl or triphenyl, especially this R group of gallium, it is butyl or phenyl. That is when triphenyl gallium or tributyl gallium is mixed with trichlorogallium, then there is an exchange of halogen and alkyl group between two gallium atoms, and we get new organometallic compound, that is diphenyl chlorogallium. Three molecules of this diphenyl or dibutyl chlorogallium is formed. This is new organometallic compound. Another example is when trialkyl boron is mixed with trihalogen boron, where this R is any alkyl or aryl group and X is, of course, it may be fluorine, chlorine or alkoxy group. Especially in case of boron, this X, it can be fluoride, chloride or alkoxy group. So when trialkyl boron is mixed with this another derivative of boron, so there is an exchange of halogen and alkyl group between two boron atoms, and we get new organometallic compound, dihalogen alkyl boron or dialkyl halogen boron. We get mixture of these two organometallic compounds. Similarly, when tetraalkyl germanium, it is mixed with tetrachlorogermanium, then there is a redistribution of halogen and alkyl group between two germanium atoms, and there is a formation of new organometallic compounds, that is a mixture of trialkyl chlorogermanium or trichloroalkyl germanium. Another example is when tetraalkyl derivatives of tin and tetrachloro derivative of tin interact under different conditions, a wide variety of new organometallic compounds are formed. For example, when tetraalkyl tin is mixed with tetrachlorotin at 273 to 293 Kelvin, then we get a mixture of trialkyl chlorotin or alkyl trichlorotin. We get a mixture of these two organometallic compounds. When temperature is increased, at high temperature actually these compounds, that is trialkyl chlorotine and alkyl trichlorotine, they react with each other, and at high temperature, that is 450 Kelvin, we get new organometallic compound, that is dialkyl dichlorotane. Similarly, when tetraalkyl tin, 3 moles of tetraalkyl tin is mixed with or treated with or allowed to react with tetrachlorotane, 1 mole of tetrachlorotane, here proportion of trialkyl tin is to trichlorotine is 3:1. That is, when excess of tetraalkyl tin is mixed with 1 mole of tetrachlorotane, then slowly there is a formation of trialkyl chlorotine. This is new organometallic compound. So all these reactions are the examples of redistribution reactions of organometallic compounds. And the next reaction of organometallic compound is complex formation reaction. Now some organometallic compounds shows a tendency of expanding their coordination number by self association or by coordination with suitable ligands such as amines, ethers, etc. This reaction, it is called as complex formation reaction. And here most important thing is the organometallic compound here act as a electron deficient compound, that is Lewis acid. So electron deficient organometallic behaves as a Lewis acid, and it accepts pair of electron from strong electron donating groups from the ligands, and there is a formation of complex. And this complex formation, it is considered as acid base reaction. Here organometallic compound act as a Lewis acid, and the suitable reagent of the 15th group element like trialkyl nitrogen or trialkyl phosphorus, like that, or trimethyl arsenic, trimethyl antimony, these act as a electron rich compounds which act as a ligand or base, Lewis base, which donates pair of electron towards electron deficient organometallic compound. So Lewis acid base reaction takes place, and it results in the formation of new organometallic compound. For example, when dialkyl beryllium is mixed with trimethyl nitrogen, here dialkyl beryllium act as a, already it is an electron deficient compound, act as a Lewis acid, whereas trimethyl nitrogen, it is electron rich compound, nitrogen is having lone pair of electron, and it acts as a Lewis base. So acid base reaction takes place, and there is a formation of complex. So this is the complex. Now the Lewis acid strength for group 3 trialkyls follows the order trialkyl boron. It shows least Lewis acid strength, and it increases from trialkyl aluminum to trialkyl gallium, indium and thallium. In this way, trialkyl thallium, it is the strongest Lewis acid, and trialkyl boron, it is the weakest Lewis acid among the various group 13 elements or trialkyls of various group 13 elements like boron, aluminum, gallium, indium and thallium. So greater is the strength of Lewis acid, greater is the reactivity towards complex formation. Here trialkyl thallium easily forms complex because it is a strong Lewis acid. Similarly, the strength of Lewis base follows the order trimethyl nitrogen, it is the strongest Lewis acid, then trimethyl phosphorus, trimethyl arsenic, and trimethyl antimony. So trimethyl antimony, it is weakest Lewis base, and trimethyl nitrogen, it is the strongest Lewis base. So out of various trialkyl derivatives of trialkyls of group 15 elements, so trimethyl nitrogen, it is the strongest base, and therefore it readily forms the complex with suitable electron deficient organometallic compound like trimethyl thallium. Now most important thing is the organometallic compound of aluminium, that is dimer of trimethyl aluminium. It forms simple Lewis acid base complex with triethyl nitrogen. So it reacts with triethyl nitrogen and there is a formation of complex. Now during this reaction there is a breaking of bridge bond of the alkyl aluminium or organometallic compound of aluminium. This Al2 CH3 undergoes bridge cleavage, and which is the bridge here, aluminium CH3 aluminium. There is a bridge between two aluminium atoms and this bridge is formed by CH3 group. So there are two AlCH3Al group and this AlCH3Al bridge, and that bridge bond is weak, it easily breaks, and therefore there is a formation of complex. So this is also very important, and most important thing again, it is the dialkyls of main group 16 also able to form the complexes. For example, the dialkyl dichlorotellurium able to form complex with quaternary ammonium salt, and this reaction is also the acid base reaction. Here quaternary ammonium salt act as a base and dialkyl dichlorotellurium act as a Lewis acid, and there is a formation of complex. So in this way organometallic compounds of main group element, they are able to form the complexes, and complex formation, it is a Lewis acid base reaction.